All right, y'all. Welcome to our specific heat day. Specific heat for our thermochemistry. We're going to be looking at pages 6 and 7 in our thermochemistry homework packet. All right, this answer for number 1, specific heat is measured with which units, is on the back of your periodic table. Okay, if you look back here, it talks about heat gained or lost. So Q equals MC delta T. We're looking at the heat gain Q, MC delta T. Okay, and then it happens right here as well, where it says specific heat is measured in those units. It is a weird set of units. It is joules per gram degree Celsius. Okay. Number 4, we're looking at delta T. So remember delta, that triangle, means a change in. So when it says delta T, that's math talk for what's the change in temperature, just like we did delta H the first day of this unit. So it says, number 4, in lab, 35 grams of aluminum is heated to 100 degrees Celsius, then placed in a cup of water. I'm going to box that in. It's heated to 100 degrees Celsius. The final measured temperature after 2 minutes is recorded at 42.8 degrees Celsius. What is the change in temperature? Okay, so our change in temperature is always going to be where we ended. Where are we? Minus where do we start? What's our change? So what's my change in my bank account? What is it now versus what did it start at? Okay, that same idea. How much weight did you lose? What's my weight now minus what did I start with? Okay, so change in temperature, we're going to say our final temperature minus our starting temperature, which means we need to figure out which one's my final. So it was heated to this, and it even says the final measured temperature is there. So this is going to be my TF, my final temperature, which makes this my TI, my temperature initial. So for this one, I'm going to say 42.8 minus 100. Okay, 42.8 minus 100 is negative 57, and that's right. I cooled down by 57.2 degrees. It was hotter and it got colder. So the change in temperature was 57.2 degrees colder. So make sure you are putting negative 57.2. Okay. Consider this table of elemental specific heat capacities to the right for questions 5 through 7. So I've got a bunch of different elements, and then their specific heats. So remember we looked at this. The bigger the numbers, the more energy it takes to heat this up, 1 gram of it up by 1 degree. So lithium has a pretty high specific heat. It means in the daytime it doesn't get hot very fast, and in the nighttime it doesn't get cold very fast. It's hard to change its temperature. Down here at the bottom, iron has a very small specific heat, which means it takes a little energy to get it hot or to get it cold. Okay? So for number 5, it says, which element's temperature would increase fastest when left out in the sun? Specific heat is the ability to change temperature. So this one, high, that would go slow. This one, I would say iron. Iron is going to heat up really fast in the day. It's also going to cool down really fast and get coldest first at night. So which one would cool fastest in the dark? That one is still iron. Okay, they're both iron. How did you know? Because it has the lowest specific heat. Which means it's easy to change temperature. Smile face, kind of. Alright, we're not going to do number 8 on this video because number 9 is very similar to it on the back. For number 9, box in your givens, right, and circle your unknowns. That's still a thing? Yeah, it is. In a lab, a student wanted to calculate the heat gained or lost by heating lead shot. Okay, it's a calorimetry type lab. The student heated, I'm going to box this in, 15 grams of shot that has a specific heat of 0.127 joules per gram degree Celsius. The initial temperature of the shot was 21 degrees Celsius, which is really cold. And the final temperature of the shot was 210 degrees Celsius. How much heat was gained or lost? That's what they're asking me. How much heat was gained or lost? Okay, so I have 4 things boxed in as givens and 1 thing written as my unknown. Okay, so 4 things means 1, 2, 3, 4 things. This is my equation. I'm going to rewrite it up here. Q equals mc delta T. Okay. And they're asking me how much heat was gained or lost. Look at that. They're asking me to find the first thing, Q. That's my X. So I'm going to write that as X. They're asking me to solve for X. What is my Q? Q equals mass, M, which is right there, grams. So instead of rewriting it out as a list, I'm just going to say there's my M. It has a specific heat of, and specific heat you don't have to memorize. M is mass. The C is the specific heat. So there's the C for my equation. And then delta T I have to calculate. Change in temperature, just like we were doing on the front of this page. Okay? So delta T is my final temperature minus my starting temperature, my initial temperature. So it says the initial temperature, so there's my Ti, and the final temperature, there's my Tf. Okay, so let's start by finding the change in our temperature. Okay, so I ended at 210 degrees Celsius, and I started at 21 degrees Celsius. So my change in temperature, my delta T, is going to equal 189 degrees Celsius. And that's a positive. It's not always positive. In this case it is, because it got hotter by 189 degrees Celsius. So let's plug in what we know. I am solving for X, or I'm solving for Q if you want me to do that. Q equals M, which I boxed in, 15, times C, which is 0.127, times delta T, which we learned was in positive 189. And there's no algebra to do, because my unknown is already by itself, so I just combine like terms. That times that times that. Okay. 15 times 0.127 times 189. My answer is 360.0. And then remember, that's that crazy unit, joules per gram degree Celsius. Oh no, wait, that's for specific heat. Okay, you can flip it over, I'll show you. We just say joules. Okay, Q, the unit is joules. I apologize. Let me even get my white out so that looks better. Joules. Okay. Number 10, let's box and circle. A sample of water absorbs 3,010 joules of heat, and the temperature increases from 35 degrees Celsius to 44 degrees Celsius. It's asking me what mass of water, so I can circle that, is used in the sample, and it tells me the specific heat of water. Okay, so in this case, it's asking me to find M. Alright, I'm solving for mass. So I know that joules, this is the heat. Okay, it's absorbed that much heat, so that's my Q. I'm going to even write that. I'm going to label it in red. This is my Q for the equation. The temperature increases from this, so that's my first temperature, my Ti, to this, so that's my Tf. It's asking me to find mass, and it tells me C. So I can start plugging that in. Q equals mc delta T, okay, where my Q is 3,010, equals mass, which I don't know, so I'm going to leave that as M, times my specific heat, 4.18, times delta T, which I need to calculate. So that would be my final, where am I now, minus where did I start. So 44 minus 35. Okay, 9. So my change in temperature is 9 degrees. Alright, this one takes some algebra. First thing I want to do is combine like terms. There's nothing to do on the left side. On the right, I can multiply those two numbers. So 4.18 times 9 equals 37.62. So it's M times 37.62. Okay, now all I can do is the opposite of multiply by 37.62, which would be divide. I'm going to divide both sides, 37.62. okay, which would give me m all by itself. So 3010 divided by 37.62, 80.0. Okay, and I'm even just going to put 80.0. Okay, and m, it's asking me for mass, which is grams. Okay. Pause it and try working this one out, please, first, and then you can come back and see what I did. I'm going to start by boxing and circling. Use the information table below to predict the identity of an 80 gram, so there's my mass, sample of a metal, that gains this much energy, so heat gained, that's my Q, when its temperature increases from this starting temperature to this final temperature, TF, by solving for specific heat. Okay, so I'm looking to solve for C, and then based on what my answer is, I will be able to figure out what the metal is. Okay, so if that's my equation still, Q equals mc delta T. I know what Q is. It's 1,560 equals my mass, 80, okay, times C. I don't know what that is. Delta T. So I want to go my final energy, and I'm going to do it down here. My final temperature minus my starting equals 30 degrees. Okay, so looking like that. All right, so 80 times C times 30. I can multiply 80 and 30 to start with. So 80 times 30 equals 2,400 times C. Okay, and that's still 1,560. So to get C by itself, I need to unmultiply, which is divide. So I'm going to divide both sides by 2,400, which make that cancel out. So C is going to equal 1,560 divided by 2,400, 0.65. So that's my answer, 0.65. And it even reminds you the units are joules per gram degree Celsius. And then, what element is that? 0.65, the specific heat, would be calcium. So this is a very real-life type of calorimetry is what it's called. Based on figuring out the specific heat, we can figure out from a table of known specific heats what element we're dealing with. Okay. You need to do number 12 on your own. Make sure you're doing number 8 on the front as well. There's a handful of these on the test. If it helps, pretend like you're in your algebra class. Okay, this is just solving variables like algebra is. Good luck, y'all.